85 plus minus 2.576. Okay, then we have square root of n, yeah. So it will be 10. Okay, so it would be, my answer would not be correct. Okay, so what is the answer? Again, 80.31. That is upper or lower? Lower. Then what's your upper limit? 89.69. Okay, so yeah, that should be correct. So again, so if you look at your sample distributed sampling mean, okay, you will see this one will be your upper limit. This will be lower limit. This will be your upper limit. Okay, forget about the value that is shown here. So what happens is, if your values fall beyond your alpha, then you accept the alternative and you reject the null. Correct? Okay? So if let's say you are doing this, right, before doing a t-test or z-test, just looking at your confidence interval, would you be able to guess whether you will be significantly different or not from the mean? Yes, right? Okay, so basically, confidence interval is using the same formula that you use for calculating one sample mean, for one sample t-test and also one sample z-test. Okay, the difference is that for t-test, you are using t-statistics instead of z-statistics. Okay? So when sample is small, smaller than 30 generally, smaller than 30, 30. So sample variance is expected to show high deviation from population variance. Okay, again the population variance in this case was referring to the total variance. Okay, the overall variance. Just now, remember we only sample a subset of the sample. Okay, but when your sample size getting more and more smaller, the variance will becoming more and more different from the overall deviation. Okay, just to put it in the context. For example, if I wanted to compare the height of the whole class, the more I sample, the more accurate my result will become. Right? If let's say I only sample 10 from here, okay, and just happens that the 10 here are relatively shorter compared to any other students, then there will be a high deviation from me to the real result. Correct? In this case, Z statistics will not be accurate anymore. So that's why you need to use a t-test. Okay? Because t-test is modeled based on a smaller size. So the confidence interval in this case would be the same, except you can see from here that you change the Z sign into T. Okay? So basically, even if you want to memorize this formula, you only need to memorize once only. Generally. Okay? So for t-test, if you look at t-table before, it will ask what is the degree of freedom. Okay? The degree of freedom will be n minus 1. Okay? If you have if you have 20 samples, your degree of freedom will be 19. Okay? Then n minus 1. Okay? And also it depends on the alpha, just like z-test. Okay? Any questions? No, yeah? Right, so example. Is the mean blood pressure for male equal to female? Is the mean change of temperature between 1900 and 2000 the same? Okay? So in this case, our null and alternative hypothesis, this is two samples. We are comparing two samples, yeah? So we have, let's say for example, male, we have, this is the mean for male. This is the mean for female. Okay? So we compare whether null is that, okay, our null would be that the mean of this minus the mean of this equals 0. If the mean of this and the mean of this is the same, meaning that the two groups will have no difference. Correct? Okay? So if we found that when you minus the mean of this and this, there's a difference. So that would mean difference between the two groups, correct? Right? Okay, so that will be the confidence interval calculating for the two different means. Okay, so comparing to the first one we will only look at one mean. Okay, so this one is to look at two different means. Okay, so for the first one, you can use the z-test or t-test, right? The second one, you can also use z-test and t-test depending on number of samples. Okay, but for the example given here, I'm using test, I think. Oh, sorry, z-test. Oh, both z and t-test. So we start with z-test first. Anyone get confused? Okay, I'll just have to go back, yeah? So this one is single sample. Can you see on the title here? Okay, this is for single sample. And this is also for single sample. Okay, this is also for single sample. Then after that we come to two samples, two means. Okay? So for one mean you are looking at whether the one mean that you measure is significantly different from the expected mean or not. Okay? Whereas when you are comparing two groups, you are looking at whether this group and this group, the mean, is there a difference between the mean between group 1 and group 2. Okay, so your null is x1 minus x, the mean from first group and the mean from second group, no difference. That is your null. Your alternative is that if you minus the mean of first group with the mean of second group, you get a value. Okay? So we can try with this. This is the formula. So control a 95% confidence interval for systolic blood pressure between male and female. Okay? So this is the formula. Can I give you 2 minutes and try to use this formula and see whether you can get the upper limit and lower limit?